Hey everyone, welcome to the Unit 6 review. Here I'm going to do everything on the left side, and you take care of everything on the right side. So let's get started. Number 1, given f of x equals negative x to the third plus 4x minus 9, on which intervals is the graph increasing? So I made this note. Remember, just look at the x values, and then you're going to do menu 6, 2, or 3 to find the local min or max. So we need to type this into the graph in order to find our answer. So let's do that right now. Okay, so here's a screenshot of the graph, and here you need to know your local min and max. So I have a negative 1.155. You just look at the x values, and a positive 1.155. So the graph is going down, up, down, right? So where's the graph increasing? I'm just going to answer the question of increasing and decreasing. So I'll just put increasing, and so increasing, well, it went down, then up, and down again. So it's only increasing between these 2 points right here. So it's only increasing between negative 1.155 and positive 1.55. And so we just list the x coordinates. All right, and so it looks like a point, but really it's an interval. So yeah, that was the increasing answer. So let's just take care of the decreasing answers. So there's 2 decreasing intervals. And remember, you're just looking at the x value, so you're looking at it from left to right. So I know the graph starts up here, but it's coming from negative infinity because it's coming from the left side of the graph. The key thing is to just look at the x value. So is it coming from the left or the right? It's clearly coming from the left. So the left side is negative infinity. The right side's positive infinity. So it's coming from negative infinity, and then it's turning at negative 1.155. So I'm going to write negative infinity, comma, negative 1.155. And then there's another answer. Where else is it decreasing? It turns at 1.155, and then it's going down and to the right. So it doesn't really matter if it's going up or down, just what direction, left or right, is it going? It's going to the right. It's on the right side of the graph. So I'm going to write positive 1.155 to positive infinity. Positive infinity always comes second. Negative infinity always comes first. So that is number 1. Number 2, you're just adding this. So if there's parentheses, it doesn't matter. Parentheses don't matter for plus. Just combine like terms. And then when in doubt, graph it out. You could totally graph this, and then you could graph your answer choices as well. But for something that's just adding, it's not going to be too difficult to do by hand. So I have a 12x to the 5th. Do I have any other powers or x's to the 5th power? No. So my answer will start with 12x to the 5th. All right. Now, do I have anything else to the 4th power? Yes, I do. So I have negative 3x to the 4th and positive 8x to the 4th. So that'll combine for a positive 8 minus 3 is 5, so positive 5x to the 4th. The powers do not change. They only change when you multiply or divide, never from adding or subtracting. So I see a negative 3x to the 3rd. I don't see any x to the 3rds here, so I'm just going to put a negative 3x to the 3rd next. All right, and then, so I had power 5, 4, 3. Are there any powers of 2? There are no powers of 2. So I'm going to move on. Are there powers of 1? I have a 2x here and a 4x there. So what's 2 plus 4? 6. So I have 6 x's. All right, and then I'm going to look at my regular numbers. So I have a negative 5 and a positive 1. So negative 5 plus 1 is negative 4. So this makes my final answer. So if you were to graph this, this would have the exact same graph as you typing in this addition problem right there. It's a lot to type in, but you'd get it right if you did that. Same idea on number 2 or 3, sorry. If you're stuck, you can graph it, but again, there's not too much work to do by hand on this. You just need to distribute the negative, everything to the right, and then combine like terms. So distributing the negative will flip the signs on all these numbers. So now I have a negative 2x to the fourth minus 6x to the third minus 2x plus 9. And so once you distribute the negative, the parentheses don't matter, so I just brought down the rest of the problem. And so now I'm going to combine like terms like I did before. I have 11x to the fourth and a negative 2x to the fourth. So 11 minus 2 is 9, so I have 9x to the fourth power. Do I have anything to the third power? Yes, I just have a negative 6x to the third. There's nothing else with the third power, so I'm just going to write negative 6x to the third, or minus 6x to the third. It doesn't really matter. And then, do I have anything else power of 2? A negative 9x squared, none of these are power of 2, so I'm going to write a negative 9x squared. Now, do I have anything power of 1? I have a plus 3x, and then a minus 2x. So I'm going to combine a plus 3 with a minus 2. So that's just going to make a plus 1. So plus 1x, or just write plus x. And then I have 11 plus 9. 11 plus 9 is 20. So again, if you were stuck on a problem like this, go ahead and graph your answer choices. This would be the correct answer choice, and this graph would overlap with this graph. You type it in exactly as you see it, parentheses and everything. Number 4, same thing. If stuck, graph the original and the answer choices, but this one's a multiplication problem because there's no plus or minus sign. So I'm going to distribute everything. So I'm going to distribute the x squared times everything. So I have x squared times x squared. You add your powers together, so that makes x to the fourth. X squared times negative 3x would make negative 3x to the third now, because this is like a power of 1 plus power of 2, you know. It's not necessary to write a power of 1, though. And then I have x squared times negative 5, so negative 5x squared. And now I have a negative 2x times x squared. So that's going to be, this is like power of 1 again, so that's going to be negative 2x to the third. So I'm going to write it right there underneath that one. And then I have negative 2x times negative 3x, so 2x's give me an x squared. And negative 2 times negative 3 is positive 6. So positive 6x squared. And then I have a negative 2x times negative 5, and that'll give me a positive 10x, because negative 2 times negative 5 is positive 10, and only one term had an x. The last thing I'm going to do is take this negative 4 and distribute it to the negative x squared, or to the positive x squared. So that'll make negative 4x squared, so I can put that right here. And then I can do negative 4 times negative 3x, so that makes positive 12x. And negative 4 times negative 5 is positive 20. So I have all my terms here now. And so the nice thing about showing your work like this is it's easier to combine like terms, because I have nothing, the fourth power, so I have x to the fourth. This is going to be kind of crammed. Negative 3 minus 2, that makes negative 5. X to the third. And then I have negative 5 plus 6, so that's positive 1, minus 4, so that'll make negative 3 x to the third. And then I have 10 plus 12, that's 22. Oh, I wrote x to the third. I should have written x squared. I mean, I already wrote something to the third power, so this one's x squared. My mistake. So this one's still 22x. Because remember, you never change the power when adding or subtracting. See, power of 2, power of 2, power of 2. That's power of 2. I just kind of misspoke. And then plus 20 is tacked on the end there. So this would be the final answer right here. X to the fourth minus 5x to the third minus 3x squared plus 22x plus 20. If you want to double check it or whatever, graph this whole statement and then graph the original, and they overlap, okay? Meaning they make the same exact graph. So number 5, it's like 2 questions in one. Is x minus 6 a binomial of all that? And then find the quotient, and if necessary, the remainder. Remember, if it is a factor, it has a 0 as a remainder, okay? So that's why I wrote if necessary, because if it doesn't have a 0 as the remainder, then it has, if it doesn't have a 0 as a remainder, then it does have a remainder. So anyway, let's do synthetic division, okay? So this is one of the problems where you can't really do it on the calculator because graphing, there's no overlapping graphs when you're just trying to find the quotient. So you're going to take that -6 and you're just going to flip the sign. And then remember, you got to write the coefficients of everything. And just make sure your problem doesn't skip any terms. It starts with the 4th power, 3rd power, 2nd power, 1st power, and then no power at all with the -12. So I don't have to add in any zeros, is what I'm trying to say. So I have 1x to the 4th, so I'll write a 1. Then I have -5x to the 3rd, so I write -5. And then I have -8x squared plus 13x, so I'll write -8. And then a +13, and then it says -12. So I'll write -12 for the last number, okay? And so now this is the synthetic division setup. Now that's done. So you bring down the first number, you get 1. And then you multiply to the outside. 1 times 6 is 6. So I'll put that here, and then I'll add those two together. -5 plus 6 is 1. So I'll multiply that to the 6, and that'll get me 6 again. So -8 plus 6 is -2. So I'll multiply the -2 times the 6, and that'll give me -12. So I'll add that with a 13, and that's a +1. And 1 times 6 is +6. So -12 plus 6 is 6. So the last number is my remainder. And so since the remainder is not 0, it's not a factor. Okay, but other than that, I still want you to write the quotient. So remember, we started with x to the 4th, and with synthetic division, we're dividing it by an x term, so my answer is going to go down by a power. So this will be x to the 3rd, this first number, and this one will be x squared, this one will be x, this will be my constant term, it'll have no letter, and the last number is my remainder. So I have 1, 1, -2, 1, so that means I have 1x to the 3rd plus 1x squared. -2 means -2x, and then what was that constant term? Plus 1. And then my remainder was a +6, so I'll write plus 6 all over, what was I dividing by? X minus 6. Okay? So if you're asked to just divide and get the quotient, you could type in this whole statement divided by x minus 6. And then you would graph this would be the answer. Those graphs would overlap. But if I'm just asking you, is it a remainder or not, that's a yes or no. Is it a factor of it? Do the synthetic division and just pay attention to the last number. You don't have to do this part as well. Okay? So that's why I said number 5 is kind of like 2 questions in one. All right? So number 6, this is a long division problem because you can't do synthetic division if there's a number in front of the x, or if the x is greater than power than 1. Technically, you can do synthetic division if it's a number in front, but it gets kind of complicated, and so let's just do long division. It's actually simpler. So I'm going to write 4x plus 3, or was it 4x minus 3? No, 4x plus 3. And then bring down the rest. 12x to the 3rd minus 11x squared plus 9x plus 18. Okay? So the key is to focus on the outside terms only. So I'm going to do 12x to the 3rd divided by 4x. Well, 12 divided by 4 is 3, and x to the 3rd divided by x is x squared. All right? So basically, you just take 3x squared and you multiply it times 4x plus 3. And then you subtract that out. So let's see. 3x squared times 4x should give me 12x to the 3rd. That first term always has to cancel out. And then I have to do a 3x squared times a positive 3. So that'll make 9x squared. So plus 9x squared. Make sure you use parentheses on this step because we're subtracting out this statement, so you have to distribute the negative. So these cancel out, but then I'm doing negative 11 minus positive 9. So I have two negatives. Negative 11 minus 9 is negative 20. So now I have negative 20 x squared. And then if you want, bring down the rest, 9x plus 18. All right? So now I just have to do negative 20x to the second power divided by 4x. So negative 20 divided by 4 is 5. So I'm going to put, or negative 5, so I'll put minus 5. And then x squared divided by x is x. So I'm doing negative 5x times 4x, so that's negative 20x squared. And then I'm doing negative 5x times 3. So negative 5 times 3 is negative 15, and then it has an x by it. All right, so I'll put it in parentheses, and then I'll subtract. So I have these two terms that cancel, and then I have a 9 minus negative 15. So that turns into 9 plus 15, which is 24. So I have 24x, and then bring down that plus 18. So I have 24x divided by 4x. Well, the x's would cancel, and so I'm doing 24 divided by 4, which is just 6. So I'll put plus 6. And so I'm going to do 6 times these two. 6 times 4x is 24x, and 6 times 3 is 18, so plus 18. Put it in parentheses, and then you'll notice everything cancels out. That cancels 18 minus positive 18 is 0. So this makes my final answer. So if this problem is kind of too exhausting for you, which I understand, just graph the original and graph your answer choices. They'll overlap. This is the original. Graph that whole statement, the dividing statement. This graph will make the same graph as that. But yeah, hopefully that didn't feel too bad though. All right, let's move on to number 7. I have to factor this completely. This is going to be factored by grouping. So I'm going to take this and factor this, and then I'm going to take this and factor that. I'll factor them separately. So what's the greatest common factor between x to the third and 3x squared? They both have an x in common. And what's the highest power that they have in common? I can take x squared out of x squared, and I can take an x squared out of x to the third. So they have an x squared in common. So basically, you're dividing out x squared from these two terms. So if I take an x squared away from an x to the third, all that's left is an x. And if I take an x squared from a 3x squared, all that's left is the 3. Okay? And then here with this minus 7x and minus 21, they both have in common a negative 7. I can divide both by negative 7. If it's negative, you should probably divide out by a negative if just this first one's negative. So divide both by negative 7. So that'll leave behind a positive x, and then this will leave behind a positive 3 because negative 21 divided by negative 7 is positive 3. So the idea with factoring by grouping is you have these two as exactly the same. If you had like an x minus 3 here, it's because you didn't divide out a negative 7, you divided out a positive 7. Okay, they have to be exactly the same. So here I have x squared minus 7. So you can group the outside terms together, and then you group the inside terms together, but you just write it once. You don't put power of 2 on the outside. Okay, that would make it wrong. And then this is a type of problem that you could graph. This answer choice right here, x squared minus 7 times x plus 3, would make the same exact graph as this. Okay, but yeah, this problem is actually done right there because I can't factor down x squared minus 7 any more than it is like that. Okay. So number 8, it's another factoring problem. Factoring problems can easily be done in the graphing calculator. You just graph the original, graph the answer choices. This has a letter that's not x, so make sure you change any letter to x. But this is a difference of squares problem. Difference of squares has to have a minus sign in the middle, and both terms have to be able to you have a square root. Okay, so the square root of 49 is 7, and the square root of k to the 4th is k squared. So I have 7k squared, and the square root of 9 is 3. So the formula tells you to just write 1 plus and 1 as minus. So I'll put 7k squared plus 3, and then I'll write 7k squared minus 3. And then let me change this to black, so I'm drawing extra attention to that. So what you do now is, can you factor any of these down? Now, if there's a plus sign, there's no sum of two squares pattern, but is this a difference of two squares? Can I take the square root of 7k to the squared? Can I take the square root of 3? No, I can't. So if I could, I'd have to factor once more, but because I can't, this is as simple as it is, as it gets. So yeah, if you're stuck, graph it out, but hopefully that didn't seem too bad. Number 9, this is x to the 3rd plus 64. So this is a sum of two cubes pattern. There's a sum of two cubes pattern, and then there's a difference of two cubes pattern. The only difference is the sign in the middle. All right, so this one is a plus, so I'm using the sum formula. Okay, there's only a difference of squares formula, but there's not a sum of squares formula. Okay, anyway, it says a to the 3rd plus b to the 3rd equals all this. So write each of these as something to the 3rd power. In other words, take the 3rd root. So in your calculator, you'd have to hit, what button is it? That control caret button. And then you can put a little 3 in the root. And so you do the cube root of 64, and that's 4. Another way of doing it is typing in x to the 3rd power in the graph, and then pressing Control T and looking at the table. And then when you see x is 4, y would be 64. So the point I'm trying to make here is I can rewrite this as x to the 3rd plus 4 to the 3rd. All right, and so I'm going to use this for a and this for b. So to factor this, I'm going to write, the formula says a plus b, so it'll say x plus 4. And then it says a squared, so that's x squared. And then it says minus ab, so that's minus x times 4, so minus 4x. And then plus b squared. What's 4 times 4? 16. So that's the answer to this problem. And this graph has the exact same graph as x to the 3rd plus 64 if you get stuck, okay? Number 10 is just determine the linear factors for this expression here. So you just need to remember the factors of the constant term over the factors of the leading coefficient. So my constant term can't have any letters by it, so that's this number here. And my leading coefficient is a 1. It's just whatever number's in front of the highest power. So make a little list of your factors. The only factors of 1 are plus and minus 1. Every time you do the factors, use plus or minus. And then what are my factors of 32? My factors of 32 are 32 and 1, so say plus or minus for both of them. 16 and 2. And let's see here, 8 and 4. And I think that's everything. Yeah, that's got to be everything. So to list my possible factors, you're going to take the factors of the constant term here, and then divide it over the factors of the leading coefficient, which is just 1. So all the possible linear factors are going to be 32 over 1 plus or minus, 1 over 1. I'll just fill out the whole list. I'll just put all these numbers over 1. And then technically those all make whole numbers, but I'm just trying to show my work. So yeah, I have 32 over 1, 1 over 1, 16 over 1, 2 over 1, 8 over 1, 4 over 1. I just literally went down the list to get my answer. So these are all possible factors of it. That's all we're asking for on this equation. You don't need to determine the exact linear factors, just the possible ones right there. I'm going to make this comma look a little neater there. So yeah, let's do the very last one. Given the graph, give the factored polynomial function. For that, we need to identify the zeros. Okay, so where are my zeros? So I'll just write zeros right here. And this graph is going by 2. See, it goes 0, 0, blank, -4. So this has got to be -2. This is +2, 4, 6, 8. So it's counting by 2s. So this looks halfway in between. So it looks like there's a 0 at -1. It looks like there's a 0 at +2, and then +3. That looks halfway in between. So I'll put -1, 2, and 3. And so remember, you just flip the signs. So if I just flip the signs, I'm just going to write x plus 1, x minus 2, x minus 3. Because if you plug in a -1, that'll make this go to 0. If I plug in a +2, that'll make that go to 0. If I plug in a +3, that'll make that go to 0. That's why they're called zeros. All right? And then you can check this on the graph by graphing this answer choice. And then if you are having trouble seeing the zeros, remember it's just menu 6-1 to find any 0 on the graph. So menu 6-1 if you need that extra bit of help. But other than that, as long as you can clearly identify the zeros, just flip the signs and then plug it into your equation, and you should be good. So I know this is a long video, so thank you for watching, and good luck on your test. Like and subscribe if you want. Bye.